One of the very important stages in machine learning is called data cleaning and understanding. In this stage, we understand what the data is, how is the data populated in each of the fields, and we clean up the data by removing some unwanted fields. This is an extremely important stage in machine learning, often overlooked and underappreciated. In my own personal experience, I've spent anywhere from a few hours, even sometimes a few days, just performing data cleaning and understanding. Actually, the more I understand about the data, the better I am able to design models. So even though people often overlook this and directly go into the modeling stage, but it's very, very important to understand data. If you do not do this step, or if you spend too little time doing data cleaning and understanding, your models will suffer. So let's take a simple example of what data understanding looks like. Okay. So earlier we noticed that in our so this is the in our previous video, when you saw a few sample products, we saw that color is none, which means it doesn't exist for some of the products. Similarly, when we saw some of the price is missing for some products and things like that, right? So let's go and understand what data is missing, what data is present, and how to handle some of these things. Okay, so let's go and understand the statistics or some basic numbers about each feature. Let's start with our feature, which is product type name. This feature should hold things like, what is the type of the product? Is it a shirt or a t-shirt or a sweater or a hat or a pant? What is it? Okay, so you can simply understand about a feature. So I'm just data is the data frame in which all of my data is stored. I'm just using the product type name field or feature, and I'm just using a describe function here. What it gives me is some very interesting data. It tells me that for 183,138 rows, this feature is present, which means this feature is present in 100% of rows, right? Because if you look at it, our data is like a table, right? And this is one feature, the product type name. The product type name is one feature. It's present. It is present in all of the rows. That's what it says. And there are 72 unique values, as you see here. There are 72 unique values of product types in our data set of 183,000 products. And the top most found product type is a shirt. And shirt is present in 167,794 products. So if you divide 167,794 by 183,138, that's roughly 91.62%. And what this means is 91.62% of our products are shirts, right? That's expected because the way we collected this data, we acquired this data from Amazon product advertising API. We searched for women's tops, right? Using Amazon's own API, we searched for women's tops. Of course, in tops, most of them should be shirts. Of course, not pants, right? So this is obvious, right? That for most of these products, the product type is a shirt. Now let's go and understand some more aspects of it. Now I want to understand what are all the unique product types that I have. And that's very simple again. I just said data product type name dot unique. Dot unique is a very useful function which tells you what all are the unique types of products that you have in product types that you have in your data set right now. The data set of 183,000 odd products. Okay, so you'll see shirt, sweater, etc. But now I have one more question here. The question is, what are the 10 most frequently found product types? What are the 10 most frequent product types? Remember, at every stage, for every snippet of code, I'm basically asking a question, trying to understand what is the data, right? That's what I mean by data understanding. You ask questions, you be Sherlock Holmes and try to get what the data is all about. So my next question is, what are the top 10 most frequent product types? Okay, so that's again very, very simple code. It's just 2 lines of code, right? It's extremely simple. Now with these 2 simple lines of code, I can get the top 10 products. Of course, the topmost product type here is shirt. The second topmost product type is apparel. Remember, there is a huge difference here. This is 167,000 and this is 3,500, right? There are some more small categories, books 1973 and later. I'm not sure why this came up, why this type of product type came up when we acquired data. Of course, there are dresses, there are sporting goods, obviously. There will be some women's tops which are sporting. There will be sweaters, of course, outerwear, outdoor recreation products, undergarments and accessories. Yes, all these types of products are possible. But look at one very fundamental observation here, that shirts are the most frequent product type. Rest of them are actually very few in number, relatively speaking to shirts. Okay, that's the takeaway from understanding product type, name, feature. Now let's go and understand other features. Let's look at brand now. Okay, for brand, I'm just using the same functions again. When I do describe, what I get here is that brand is present in 182,987 rows of data, which means there are only 151 rows or only 151 products where the brand name is missing. Okay, so in a total data set here, if I take the column brand, okay, there are only 151 rows where the brand name is missing. Okay, because the total number of rows is 183,138, and in 182,987 rows, the value of there is some value for brand, which means for 151 it's missing, which is okay, which is a small number compared to 183,000. Now there are about 10,577 unique brands, or lots of types of brands. That's important. And the topmost brand is called Zago, and this topmost brand is present in 223 rows. Okay, so this seems like interesting. We have about 10,000 brands in a total data set, which is a pretty good collection, to be frank. Now again, I continue with the same thought process, which is what are the top 10 most brand types? Okay, and the same two lines of code that I used earlier, but here now I'm doing it with the featured brand or the column brand, right? Now I get these top 10. Now if I recall, okay, the topmost is Zago with 223 rows or 223 products from Zago. There are 222 products from XQS and so on and so forth. This seems logical. It's not like a previous case of product type where shirt product type was most frequent and others are very few in number. Here there is a good spread of brands here, and we have about 10,000 brands, right? And brand is mostly present except for a small number where it's missing. For most products we have a brand except for a very small number where it's missing, which is good to know. Now let's go and understand the field color or the feature color. Now if you look at it, color is present only in 64,956 rows. Again, I'm using the describe function, right? And there are 7,380 unique colors. And the topmost color is black, and black is found for 13,207 products. Now let's understand. So we have 7,380 unique products. 7.2% of products are black. I can easily get that, right? 13,207 by 183,138, right? Now, since only 64,956 products of the 183K products have a brand information, that's approximately 35.4%, which means 35.4% of our products have color information. Rest of them we don't have color information. Okay, and now let's look at what are the topmost colors in our data set, right? Okay, again I use the same function here. Of course, the topmost is none, because in 118,000 for 118,000 products it's actually null or none, right? In Python, none basically means it's empty. So for 118K products, we don't have a color at all. And the most often found valid color is black, which has 13,000, which is present for 13,207 products. Similarly, white is present, blue is present, etc. There is also a field called multi, because a lot of women's tops have multiple colors on it. There is also a star. I don't understand what it means exactly, but there are 1,388 products with a star color, which seems illogical to me. But let's continue. Let's flow with this. Okay. So remember, understanding that there is a value like star, understanding that there is a value like multi are very important, because they give you a perspective on what the actual data is. The real world data is going to be crazy. If I have to put if I have to put it in single word, the real world data is never well behaved. It's always crazy. You'll have to clean it up. You'll have to tame it properly, and that's what we're trying to do. Now let's look at the next field, which is formatted price, right? So of course, formatted price is only present in 28,395 rows, and there are 3,135 unique price points, and the topmost price point is $19.99, and it's present in 945 products. Okay, it makes sense, right? Most women's tops are around $20, so it makes sense. Now, one thing that you have to notice is only for 28,395 products we have price information. That's roughly like 15.5%, because the total number of rows is about 183k, right? So if you divide 28k roughly, you get about 15%, right? Which means about only for 15% of your data points you have a price. Probably Amazon through their API is not willing to give us all the data, especially price information, which is extremely important for their business. Okay, now let's go and understand what price points. Again, I'm just using the top. I'm trying to get the most frequent prices here using the similar code snippet. And what we have here is it's missing for a lot of them. None basically means that there is no value. And there are values from $19.99, $9.99. All these numbers look same. They look sensible. Now let's go and understand about the feature title, right? Because title is one of the most important features that we will use. Truth be told, title is the feature we will use. Again, just to repeat myself, titles are short and very informative, and they're super informative. So we will use titles extensively, but let's see if titles are actually present enough number of times, right? So again, I just use the describe function here. Oh, wow, this is great. So almost for all of my products, I have a title. That's good to know. And there are about 175,985 unique titles, which means for most of my products, for a large number of my products, my titles are unique. Okay. And this is my top. Wow, there is a kurti here. Interestingly, I actually got this data from Amazon.com, but I still find an Indian wear. That's interesting to know. And this is found 77 times, right? So the most important thing is titles are short and very informative, and super importantly, they are mostly present. They are mostly present for every product. They're mostly present for every product, which makes them the best feature, the best snippet of information that we can use for our whole exercise. And we will use this extensively, trust me. Okay, now once we have done all of this, what we'll do is we have got some understanding of the data of each field, right? Now what I'm doing here is I'm storing my data right now into a pickle file. So you can think of pickle files as basically a way to store. So when I say data.toPickle, now I want to store data into a file. So I have a folder called pickles, and I'm storing it in 180k apparel data. Now, whenever I want, so this is like storing a variable. Through this, I'm storing data variable to disk, to my hard disk. Right now, whenever I want this, I can actually get this variable right now back into my code. So we actually provide these pickle files. These are called pickle files. We actually provide these pickle files so that whenever it takes too long a time for you to run code, you can just load the pickle file, and at the end of every stage we store our pickle files. Right? So pickle file is basically a simple way. This is what Python provides you by the pickle files are Python specific files which can store variables, any variable. So data is a variable, right? Data is a pandas data frame variable. Now we can store any variable into a pickle file and load it later. Okay. So the pickles folder that you have on the Google Drive that I shared with you earlier, it has basically all the data variables. At every important stage we store them, so that if anybody gets stuck anywhere, they can just load this pickle file, or if it takes too long for something to run on your laptop, you can just load this pickle file and things will be simplified. Okay. And okay, now having understood a little bit about pickle files, let's do some simple processing. Okay. So before we go ahead, I wanted to explain you something. Even though for almost 183K products, we have titles, right? And as I mentioned to you that we want to use titles extensively throughout this workshop, I thought that when we tried to run our code on all 183,000 products, it was taking too long, right? Even on fairly powerful desktops and laptops, because processing text, there are a lot of small interesting operations that take a lot of time. So what we did was, just in the interest of time, we said instead of operating on all the 183,000 data points, can I operate on a subset of data points, which is small but not too small, right? So we said, what if I remove all those rows where some data is empty? Okay, so for example, can I remove all the rows where the price is empty? And that's very, very easy to do it. How do we do it? So I can just say, so data formatted price is null. This will return me if the formatted price is null or doesn't exist. And I'm doing this not operation here. This is the logical not. So what I'm doing here is find me all those rows where the formatted price field is not null, because we are using the is null function and we are negating it here, right? So at the end of it, if you check, we have about 28,395 rows where the price is not null, and I'm storing that in data right now. Okay, so amongst these 28,395 products, now the next question is, how many products do we have such that the color information is also not null? Okay, and that's very easy to do, right? I'm just using the same thing. So data color is null. This will give me boolean true if the color is null, and I'm negating it here, right? So using this single line of command, I'm trying to find those data products. See, again, here data only contains now 28,395 rows where the price is not null. Now I'm also saying, of these 28,395 rows, find those rows where the color is also not null. And I'm left with 28,385 points, right? So we will operate on this 28K. This is roughly about 28K points, right? So we will operate on this, we'll continue this whole exercise on these 28K points from now on, instead of the 183K points. Because see, obviously, for those of you who have time, resources, and patience, please feel free to run this whole exercise on the 183K data points. We are only running it on 28K points so as to save time for people, because some of the code takes a lot of time. So for those of you who have time, energy, who want to run this code on all the 183K products, please feel free to do it, right? But for now, we are limiting ourselves to only 28K points. Okay, so that the code runs faster. We don't want to wait 3 or 4 hours for some code snippets to run, right? That's why we are limiting ourselves to 28K. We'll shrink this further when you do some more data cleaning. But right now, we are operating on a data set size of 28K. So what all things did we do here? We removed price not equal to null, right? And color not equal to null. So these are the filters that we put. So of the 183K, we said if price is null, don't use it. If color is null, don't use it. Rest of them, we are left with 28K. And I'm just repeating it again. We are only reducing the size so as to speed up things, for most of our participants in the workshop. If you have time, patience, energy, please feel free to run this whole workshop on 183K data points. Okay, having said that, now the key important thing here is, okay, we have brought down our data set from 183K to 28K. Now the next important thing is, of course, I'll store my 28K data points into a pickle file again, right? So this is what we'll operate on. See, at every key stage in our code, we store the variables that we care about. Here I have the variable data, and I'm storing it to a pickle file, which is 28K apparel data pickle file. So one thing you'll notice in our folders is the images of all of these 28K products is not available. Okay, but what we have is the image URL. If you recall, one of the fields that we have in our data set is the image URL. There is a feature or a field called medium image URL, right, in our data set. Now, this is a code snippet that you can use. I have commented this whole code right now because you don't have to run it. It's optional to run. If you want to get the actual images of each of our products, if you want to get the actual image, the actual physical image of each of our products, you can use this code snippet to get it, but it's not necessary to run. Remember, you're downloading 28,000 images from Amazon.com, so it'll take a while. Please be patient. But it's not necessary to run it, trust me. Okay, so for those of you who are interested to obtain all the images, this is the code snippet to run, but this is optional, and hence I have commented it out. Okay, we just wanted to give this code for those people who are interested to run this code. Okay, having said that, now let's move on. Okay, so this stage of basic data understanding, data cleaning is more or less done. There is some more work that we have to do, right? At least some parts of it we have done till now. So we've understood the importance of data cleaning, and we have brought down our data from 183K points to 28K points. Again, just to repeat myself, this is mostly to simplify processing. Those people who want to do it, who want to pursue and do the whole analysis on 183K products, please feel free.